Good afternoon, everybody. I hope you can hear me. Just making sure we're live. Somebody wants to post in the chat. Yes, I can hear you. That would be good as a test. Excellent, fabulous. So hello to everybody. Welcome and thank you for joining. I'm delighted to host this webinar today in partnership with IMechE. Wherever you're logging on from, be it at work or home, I hope you're safe and well and coping with whatever level of lockdown you're currently experiencing in these strange times. I come to you live from a corner of my living room in North London, so hopefully you can hear me loud and clear. Our topic for the webinar today is a systems approach to identifying and managing equipment hazards. This is actually the second in the series that we've been running with IMechE. The first was steam turbine safety devices, hosted back in September, which is also still available online for those of you interested. My name is Simon Baker-Chambers. I am the Vice President Manager for Global Sales in EMEA for FM Global. I will be your host today. Working alongside me today will be our presenter, Steve Shuttleworth. Steve is a Senior Engineering Specialist also at FM Global, and I will let Steve introduce himself in detail in a short while. We have a very diverse audience joining us today. We have over 600 people registered, amazingly, which is fantastic. At the moment, I think we're up to just over 200 people actually joined live. So again, thank you for joining us. A mixture of people from different industries, different companies, both IMechE members and guests, operators, owners, OEMs, consultants, and a whole bunch of other interested people. Some housekeeping issues I'll just run through with you quickly. The presentation itself will run for about 30 minutes, and I've asked Steve to go through his presentation from start to finish without a stop. If you please feel free to post your questions in the chat function as we go under the Q&A. So if you'd like to post your questions as we go, as you think of them, in the Q&A function that you can see on your screen alongside the presentation, that would be great. I will monitor those as the presentation goes along, and then after the 30 minutes, Steve will conclude, and then I will handle questions on your behalf, and I will pose those to Steve, and Steve will respond to you, and we will get through as many as we can in the time that we have. So hopefully that will go okay, and I'll be monitoring those as we go through the presentation. So we have a hard stop at 1 o'clock. Your mics and videos will be muted and turned off throughout the presentation, just so that we can run the session seamlessly. I think I've covered everything. I should just probably add to conclude that the session will be recorded for people to watch after the event, plus a copy of the presentation will also be made available to everybody that is registered. So if you're taking notes or you're interested, you will get a copy of this presentation at the end. So without further ado, welcome once again to everybody, and I will pass you over to Steve Shuttleworth. Steve, over to you.
Okay, thank you. I'm just on my screen. Hopefully everyone can see that. Okay, I am Steve Shuttleworth, and as the title slide suggests, I'm going to talk about a systems approach and how we use it to help identifying and managing equipment hazards. If you have any questions, as Simon said, please put them in the chat, and I'll do my best to answer them at the end of the presentation, which will take about half an hour. Okay, so I'll start off with a brief introduction to FM Global for those who've never heard of us, and tell you a little bit about myself, and then I'll go on to talk about the systems approach. Specifically, what is it or what isn't it? Why do we need it? How do we apply it? And then I'll move on to the exam question at the end, is it working? And summarise with some key takeaways. So, starting off with FM Global. We're a specialty and property business insurer with a long history and a unique approach to insurance. The company was started in Rhode Island over 180 years ago by a textile mill owner who started the Factory Mutual Company with other like-minded mill owners. And they all shared the common belief that the majority of loss is preventable. So together they saw the value in loss prevention engineering. FM Global still works with its clients today to provide engineering solutions to identified risks by including in-house engineering consultancy services as part of the insurance policies. Our company remains mutual and has supplemented almost 2 centuries of insured loss experience through the establishment of our own 1,600-acre research campus in the USA. We employ industry experienced graduate engineers to work with our clients as field engineers to identify, improve risks to property and minimize potential for business interruption. Unlike our competitors, we insure our clients based on engineering analysis opposed to actuarial historical information. We insure a wide range of businesses from hotels and offices all the way up to multinational corporations, including high challenge industries such as power generation and chemical manufacturing. We insure over a third of the companies listed in Fortune 1000. So that's the company. A little bit about me. My background is in marine engineering. I've worked for FM Global for 9 years. And before that, I served 34 years with the Royal Navy, where I started out as an apprentice and I worked my way through the ranks in the surface fleet, eventually leaving as a lieutenant commander. My role within FM Global is as a field engineer, and I'm employed to provide that engineering analysis of our client sites, which is used by our underwriters, as well as providing the consultancy support to our clients to help them identify risks and provide recommendations for solutions. As well as my experience in training with the Royal Navy, FM Global has its own internal sizable training organisation, and every engineer in the company must pass through the company's own training pipeline, which is usually about 18 months, before we're let fully loose with our clients on our own. We employ engineers in 2 categories, fire and natural hazard engineers and boiler and machinery engineers, which have independent but overlapping training pipelines. Quite a few of our engineers, myself included, have completed both training systems. FM Global has around 5,500 employees, of which 1,860 are field engineers, and more than 1,000 others who started out as field engineers and have moved on to other roles within the company, which means that we have this huge wealth of engineering expertise to call on. In 2016, while continuing with my day job as a field engineer, I was asked to take an additional role in the restructure of FM Global's training model for our boiler and machinery engineers. Historically, the training pipeline for boiler and machinery engineers involved quite a number of visits to client sites, where our engineers would trail other qualified engineers, and they'd spend a significant amount of time online doing technical work. And as well as that, they'd do 3 trips to FM Global's training centre near Boston in the USA for some classroom training. The training had a very clear focus on learning how equipment works and how to analyse it for the risks of it failing. And the original intent of the training restructure that I was invited onto was to repackage our existing content. But as part of the review process, we also asked for some analysis of the effects of boiler and machinery losses on our broader book of business, just to make sure we were training the right material. The results that we got, though, came as quite a surprise to many. In the high hazard industries, equipment failures and associated business interruption accounted for about 70% of all losses, and there were no great surprises there. High hazard industries tend to be housed in concrete buildings, and very often there's not a great deal else to fail. But alarm bells started to ring when the analysis showed that in the preceding 10 years to 2017, over a third of the insured losses of our entire book of business, which included all those hotels, offices, shopping malls, and other non-high hazard clients, have been down to equipment failure, and that was significantly higher than we had expected. High hazard locations made up about 15 to 20% of our insured locations, and it was becoming clear that boiler and machinery losses through equipment failure were costing us a disproportionate amount. It got worse because when we went back to ask how many fire events, part of the other 2/3 of our losses, started with a piece of equipment failing and initiating the fire, but aren't recorded as equipment failures. And there was no clear answer to that, but a resounding probably quite a lot. So the situation may have even been worse. Equipment failures were forming a much bigger proportion of our outgoings than had previously been realised. And it was becoming very clear that our old approach to training was not as effective as we'd previously thought, for a variety of reasons, but not least through a change in environment. Whilst our old methodology, the equipment-focused training, may have been effective 20, 30 or 40 years ago, against a backdrop of changing industry trends, it was no longer as effective as it could be. Those trends include increasing operational capacity for our clients, loading their equipment more, squeezing their assets and pushing the equipment beyond its original design. Reduced maintenance taken as a cost saving, or moves to condition-based maintenance, but without always monitoring the equipment effectively or creating baselines or establishing the parameters which define good condition from bad condition. Deferred maintenance through operational pressures leading to undetected premature failures. And overall, an aging infrastructure and equipment, which leads to reduced reliability, growing obsolescence. In summary, more fragile equipment, which is more difficult to repair and has limited contingencies. In many instances, we were routinely missing the real cause of insured losses, and the decision was taken to change the focus of our field engineer training away from object-driven, how do machines work, towards a systems approach. Our old approach had been, if you encounter a gas turbine, look for these things, safety devices and other physical protection. If you encounter a chemical reactor, does it have a relief valve, and so on and so on. It turned out, though, that more often than not, it was something further away from the equipment which was causing the event. And in most cases, the lion's share of the cost was down to business interruption rather than the equipment replacement. So we needed to train our engineers to gain a better understanding of our clients' risks so that we can make the right recommendations, those which would stop the insured events from occurring. When we evaluate our clients' equipment, we use 7 equipment factors, which history tells us are known to influence losses. They give us an indication of the likely frequency and severity of equipment breakdowns, where breakdowns are more likely, and hopefully they should be able to point us to where we can recommend improvements to improve reliability and resilience. The equipment factors are maintenance, which speaks for itself, operating conditions, which considers whether the equipment is being used for its original design intent. Environment, which is important. Equipment tends not to last very long under a leaky roof. Operators, and history of the specific equipment. Is it known to fail? Those 5 give us a likelihood of a failure occurring. And then the other 2 equipment factors, safety devices and contingency planning, they'll give us an indication of how bad the incident could be if it does go wrong. Our engineers rate equipment as satisfactory or unsatisfactory against each of these factors, and history shows us that this can be quite effective. Statistically, equipment with 3 unsatisfactory equipment factors, as opposed to no unsatisfactory equipment factors, is 10 times more likely to fail. And when it does, including the downtime, it's likely to be 5 times more expensive to sort it out. So going back to our review of historical losses for the training side of things, when we look back at insured equipment failures over a 10-year period that had cost us more than $3 million each, and checked which equipment factors had been marked as unsatisfactory at those locations, 3 equipment factors stood out as being marked unsatisfactory in virtually all of the events. And these were maintenance, safety devices, and operators. In the case of safety devices, where this had been assessed as unsatisfactory, usually the reports included recommendations, and if those recommendations had been implemented to improve or install safety devices, that would probably have stopped the event, or at least reduced the damage. Where maintenance had been marked as unsatisfactory, sometimes there were recommendations, but where recommendations had been made, these usually addressed specific maintenance issues, but not necessarily fixed the problem. In the case of operators, the result was the most striking. Investigation of the incident showed that in well over 60% of these insured events, the operators had either caused it or in some major way made it much worse. Yet when we looked at the reports written for these sites, almost none had any sort of recommendations for operators. On the back of this, we looked at the reports of all of our clients, and particularly for the high hazard sites that we insure, and it turned out that less than 2% had recommendations for improvement of operators. So with all this in mind, it was becoming clear that 2 of the 3 most significant equipment factors in the majority of our higher cost insured equipment losses were not adequately addressed by our training program. And this spelled out to us that we needed to teach our engineers to conduct a broader engineering analysis, which would enable better recommendations to reduce risks. So we took a decision to take a move away from equipment-focused training towards what we now refer to as the systems approach. Equipment-specific training, the how things work, would virtually all be migrated to online learning. And in the modern world, knowledge delivered as part of the training package can be augmented and refreshed easily and at any time by the seemingly infinite powers of Professor Google. I know that if I'm to visit a site with a specific piece of equipment I need to evaluate, my first port of call for a refresher is not usually the notes I made 9 years ago during my FM Global training. I consult our data sheets, which are updated regularly, and I use the internet. There is merit in teaching detailed technical topics on some specific machinery, and a good generic knowledge is essential to be effective as a field engineer. But the new focus would be that our training should deliver engineers with an expertise in identifying risks, not the detailed expertise in our clients' equipment we tried to achieve with the old training. And it's certainly true, I think, that if I turned up at a client site and discovered that I knew more about their equipment than they did, I'd be very worried about their ability to keep it safe and reliable or ensure the resilience of their business. Our clients should be the experts in their equipment, and we should focus on supporting them by identifying, removing and mitigating the risks they may not have considered. So changing to a systems approach posed a number of challenges. First of all, what is a systems approach? And how on earth do we train it to our engineers and deliver it to our clients? Our own internal operating procedures had always included the phrase apply a systems approach, but it was never really defined what that meant or how it should be done. Our new training must address that, and our documentation is now much more specific. FM Global's version of the systems approach breaks the systems down at a site into these groups. Production systems, that's things like turbine generators, printing presses, paper machine, the equipment that's right at the front end of production, the specialist equipment. Then we've got utility systems, a little more obvious sometimes, electricity, water, air, steam, and so on, those kind of things. And then we have support systems, and this includes things like control systems, other systems which are indirect but essential to production, water purification, effluent emission control systems, those sort of things. So the centre three circles in this diagram are all about the physical systems. And although we were pretty good at some aspects of this, we needed to get better at identifying which systems and equipment presented the biggest risk to our client's business. Instead of turning up on site with, "Good morning, my name's Steve, take me to your turbines," we needed to train our engineers to look at a site holistically, work out what's important to the business, and prioritise that over specific pieces of equipment that we've been taught to evaluate in the old training system. So our approach on site now is more along the lines of, "Good morning, my name's Steve. Before we go on a tour of your site, could you run through a production flow diagram with me so that I understand what's critical to the success of your business, and we can make a point of visiting those areas." We still go and look at the turbines or whatever a client has that's big, scary, or potentially expensive, but we look at the site's equipment and systems in a priority order based on risk to the business rather than heading straight to the equipment we've got history with. So the physical systems are pretty straightforward. The human element systems, the bit in the yellow circle around the outside, are less so. Judging by the findings of the research into our insured losses history, this is where the biggest changes to our training approach was needed. When we think of systems, we tend not to consider human element activities as systems, or to view them the way we would other physical systems. But the reality is that, like physical systems, human element systems also need to be appropriately designed, be comprehensive, maintained, tested, and have inherent resilience to ensure that they're effective at keeping the site in good working order. Some of the human element systems we focus on are asset integrity, which is an all-encompassing title, includes maintenance, inspection, management strategies, that kind of thing. Operators, we look at training, qualification, documentation, and so on. Management of change. In the history of all catastrophes, poor management of change is one of the most common things, whether it's introduction of a whole new production line or a temporary change on the night shift to keep things going until the maintenance team can fix it in the morning. It needs to be properly managed or it can go horribly wrong, and we've got a lot of experience that shows that. And then another human element practice, business continuity. One of our biggest costs is business interruption. So contingency planning, spares and redundant equipment are important. And these systems need to be realistic, and periodically it's a good idea to test them, because all too often when something does go wrong, the contingency plans don't work quite the way anybody thought they would. So Where historically we had classroom trained our engineers to look at the detail of specific equipment, the new approach is online training for equipment specific items, with classroom training focused around simulated visits, so role playing and applying a systems approach to analyse at a higher level, looking at strategies instead of just achievement, and casting a much wider net to capture the potential risks to our clients' businesses. To support our new approach, we also introduced a range of new tools for our engineers to apply in the field, in particular in the evaluation of some of these human element systems. Asset integrity, which is an all-encompassing heading, but should be viewed as a system to include maintenance, repair and improvement, but also look at design considerations and condition monitoring. Previously, we would have asked, do you maintain this piece of equipment? Now we ask, what strategy do you have in place to maintain the equipment's reliability? We've introduced this aid memoir on this slide to help guide us and guide our engineers to ensure that an asset integrity system is complete. And an example of where a new approach might reveal a potential risk would be the repurposing of a piece of equipment. If we took, say, a power station turbine generator, which was installed for use as a base-loaded machine, if that machine is maintained to the original equipment manufacturer's schedule and it's running on a constant load, the strategy given by the owner is probably fine and the machine is going to be fine. But if the machine is then reallocated as a peaker, started and run only at times of peak demand, the fact that the machine now goes through many more start-stop cycles and is being thermally cycled means that there's likely to be a marked difference in the maintenance necessary to maintain its reliability. So our aid memoir gives us the entire system so we can go back to the start and make sure that the strategy for that piece of equipment is correct. A good asset integrity system should start with an evaluation of the likely failure modes of the machine in its current and predicted use. It should include mitigation to limit excursions from design or intended use, include an appropriate inspection, testing and maintenance program, and address the management of defects, including how a defect's detected and assessed. And finally, how are the lessons from failure learned and improvements implemented? We don't ask to see every detail of what's being done in terms of maintenance and asset maintenance, but we want to ensure that the strategy in place and is an appropriate strategy to maintain the reliability and resilience of the equipment. Making recommendations to fix the strategy should prompt the client to find more of their own risks. So the systems approach is a strategic approach, fixing the system rather than a tactical approach, plugging each hole as we find it. Assessing some of the human element systems has historically not been done well, none more so than operators. Telling our newly appointed field engineer to go and evaluate the operators at someone's power plant or chemical factory isn't, or rather wasn't, realistic. The field engineer doesn't really know how the plant works and can't possibly have the credibility with the operators at the site. It's all very personal and potentially it could be a minefield. But if we view operators as a system, then it does become possible. An operator is, at the end of the day, an organic safety device. Very often the last line of defense, but in objective terms, an organic safety device. Like any other safety device, there needs to be a sound design in place. It needs to be set up and commissioned to a documented standard, have a set of operating criteria in place, and a reliable, known outcome when it operates. It also needs to be maintained and tested periodically to ensure it still functions. So our assessment now is of the operators as a system. So here's a picture of a turbine which suffered badly because the operator took the wrong action. Not deliberately. He acted with the best intentions, but it was the wrong action. This was a motoring event which went horribly wrong for this turbine generator, and we had to buy them a new one. When all this was over, the plant manager was asked, if you could have had your time again, which operator would you have preferred on shift that night? And his answer was, the guy who was on shift at the time was the best he had, because he always did his utmost to keep the plant online. During my own visits, I've quite often asked the same question, and it turns out that it's a very common thing. From the plant manager's position, the guy who keeps the plant running at all costs is the best operator. But from an equipment and business risk perspective, the best operator is one who knows when something's wrong, understands the limits, acts on them, and follows the emergency procedure and makes the plant safe, quite often shutting it down. It's easy for our instincts to lead us to the wrong conclusions about operators. Experienced operators aren't necessarily good operators. The ones who keep the plant running might just run it into the ground, and someone who's good at operating the plant when it's all going well might not be so good when the lights go off. So our operator evaluation now follows a more objective, structured route and looks at these areas. Strategy is the one. Does the site have a strategy for making sure that operators are up to speed? Is it realistic, and is the client achieving it? Quite often our clients think they've got a good operator training system in place and it's not working. The training program, is it documented? Does it include qualification and requalification? How do we maintain operators and make sure that they're still working the way we intended? Standard operating procedures and emergency operating procedures, are they available to the operators? Do they even exist? Are they in the control room ready to open and use, and are they practiced? If they don't exist, what on earth does the training program use to make sure that the operators know what they're doing? Management of changes. Do changes to equipment, manning, training, production, and legislation make it through as far as the training and then into those SOPs and EOPs? Alarm management. How do the operators manage alarms? Do they silence them and hope they'll go away? Do they ignore them? Or do they open the SOPs and EOPs and follow the training? How are nuisance alarms managed? Does this involve removing light bulbs or putting pieces of sticky tape over the warning lights on the panel, which I've seen? Or is there a management process in place to deal with the problems properly? And then finally, equipment status and handovers. Is there a formal handover procedure? Is it documented, and what does it cover? It's often interesting to ask what time operators are paid to at the shift end. Are they paid to the end of the shift or till 30 minutes after? Because quite often, if there's no overlap, there's no handover. And the thing about all this is, at no point in any of this process do we ask the operator, are you good at your job? Or do we ask the site management, are your operators any good? We evaluate the system. It isn't personal. It looks at the system from several perspectives, and it works. Another area, change management. A significant number of losses we deal with occur because of changes implemented without an effective management of change system. And risks are unwittingly introduced, which suddenly or eventually can lead to a failure. A jumper wire, like the one in this picture, it was installed as a temporary measure to alleviate a startup problem at a large foundry. It worked quite well, but the operating procedure had to be temporarily modified to compensate for the lack of the bypass safety device, which is what the jumper was doing. It wasn't properly managed, and eventually, in fact over a decade later, it was forgotten about. And unfortunately, at about the same time, so was the amended startup procedure. The net result was that a bank of oil-filled capacitors, as it turned out a very large bank of oil-filled capacitors, which were part of a critical part of the main electrical supply to the facility, they exploded and started a major fire. All power to the facility was lost, and actually the whole site was down for months. This is all down to management of change. If the management of change system had been effective, this wouldn't have happened. If the operator's system had been effective and the SOPs formally amended, this wouldn't have happened. But because those two human element systems weren't working, that little piece of wire potentially cost us a lot of money. The experience here should lead to the question, how many other forgotten jumper wires are there at this site or any other site which doesn't have an effective change management system? So the systems approach we've adopted is about taking a step back to take a strategic look at some of the less obvious systems which make a big difference. In particular, those systems which, if there's room for a strategic improvement, will enable our clients to identify and reduce their own tactical risks. We've still analysed the detail of production systems, but we spend a bit more time now ensuring we're looking at the right equipment and taking a lot more interest in the human element systems, which ensure its safe, sustained operation and resilience. So is our new approach with the systems approach working? One of the important things about this job is that you only really find out how you're doing when things have gone badly wrong. So we use events which have happened or ensured losses to work out what we missed. Well, the systems approach was rolled out within FM Global to our existing workforce in the second half of 2018. And all training since then has been along the new training program. And so we made a comparison between the results from 2018 and 2019 to see if there's any difference. In 2018, we had 65 equipment losses, each of which cost us more than $3 million. In total, it's many, many hundreds of millions of dollars in losses for that year. On analysis of those insured losses, compared with the reports that were written prior to the losses, just over half of the incident causes and contributing factors had been directly identified, and they were there on the reports as recommendations. And if those recommendations had been completed, they would have removed the risks. In 2019, we had 45 losses, each over $3 million. But we wouldn't be so bold as to say that, you know, the drop from 65 to 45 was due to the new approach. It almost certainly wasn't. But the same investigation of the losses compared to the reports and recommendations from before the losses showed us that now only 7% of the incident causes had been missed. Our risk capture was up to 93%, which is a marked difference. Also, the number of operator recommendations at our high hazard sites was up to around 30% by the end of 2019. So it appears that a more structured evaluation of operators through the systems approach is definitely finding shortfalls and driving the provision of recommendations for our clients on how to fix those issues. So what are the key takeaways from all of this? The introduction of a systems approach to identify risk was not an easy option, and it's always difficult to let go of the legacy, but we've always done it this way. In our move to the systems approach, one of the first steps was to define what is the systems approach and break it down into something manageable and deliverable. Our analysis of the systems that cause insured losses highlighted beyond all doubt that all too often the most important systems are not the physical ones. Critical systems don't all have pipes and cables. And what people do is just as important, in many cases more important. If we could train our engineers to accurately analyse human element systems and provide recommendations which would close any gaps, going forwards, many of the physical risks would be resolved by our clients. That said, although we're applying this new focus towards human element systems, the equipment is still very important, obviously. And we'll continue to look at that too, but as part of a more business-focused list of priorities. The whole concept, though, if I liken it to running a car, is to help our clients develop their systems which they can use to stop their wheel nuts from coming loose, as well as telling them which wheel nuts need tightening up. It's an additional, more strategic approach to dealing with the causes of the tactical problems we've always tried to address. In doing all of this, we needed to create some new tools to support our field engineers, which we've done. We needed to change our own field engineering procedures, and perhaps most challenging from a training perspective was to re-educate our existing workforce to a new way of doing business when they didn't necessarily see anything wrong with the old way. In the short term, the numbers probably aren't reliable enough to give a definitive, yes, absolutely, it's definitely working. And the last 12 months definitely haven't helped us much because without site visits, it's difficult to apply a systems approach fully. But the early signs are promising. And we're already seeing significantly more recommendations for human element system improvements. In terms of insured losses, it will be a few years before clients implement the recommendations that are generated by a systems approach. And when that does happen, hopefully we'll start to see an improvement in the ratio of insured equipment losses to fire and natural hazard losses, or a reduction in losses altogether. But in terms of being able to give our clients better advice and recommendation to improve the resilience of their businesses, the systems approach, it appears, is already a winner. FM Global was always pretty good, but the systems approach is helping us to get better. Well, that concludes my presentation. Thank you for listening. So now on to the difficult part, where I'll try and answer any questions you may have.
Thank you very much, Steve. That was excellent. I'll give you an opportunity to have a glass of water and catch your breath. Thank you very much for running us through that. Thank you also to the audience for the questions that have been coming in. I've done my best to keep track, and we have quite a few, which is great. So we've got 25 minutes, Steve. So we've got a nice selection to get through. So if you're ready, without further ado, I will kick off.
Yeah.
So our first question is from David Lindsell. What do you think the equipment trends issues are affected by a reduced operator capability or knowledge caused by what is now a very much reduced depth of training and experience? Question.
Yeah, that's definitely the trend we're seeing, and that's why the viewing operators as a system is much more important. The trend we tend to see is that people don't stay in one place as much as they used to, and one of the things that suffers is definitely training and experience of the operators. Historically, we may have been able to rely on an operator who's been at the plant for 20, 25 years and has seen the sort of failures that we're concerned about. But more and more we see operators who don't have that experience, and they're only really good at keeping the plant operating when it's doing what it normally does. So focusing on the system and making sure that the system is whole and the system recognizes what could go wrong, and the system makes sure that the operators are competent, trained, tested, and retested on a periodic basis is critical, and that's what we're focusing on.
Great, thanks, Steve. Our next question is from Aaron Haradas. I hope I'm pronouncing that correctly. Doesn't change in operating conditions also play a part and factor in the frequency?
It does. And again, that's why the human element systems to manage change effectively is so important. Any change in operating conditions, in equipment, in any aspect of a production process of any sort, needs to be carefully managed to make sure that the change is factored into all of the other systems which are so important at maintaining reliability and resilience. Things like making sure the training changes for the change in operating conditions, making sure the maintenance, the asset integrity program recognizes what needs to be changed, the provision of spare equipment, contingency planning, all those factors be changed. The management of change, which is like an umbrella or over a lot of the other human element systems, needs to be working effectively to make sure that things don't go wrong because of those changes.
Great, thanks, Steve. Next question's from Anne Marshall. How many of the operator-caused incidents happen because they have not been made aware of the O&M manuals or had training? Surely there is some potential element of foreseeable misuse.
There is. I don't know exactly what the proportions are, but I would estimate probably about half of the losses, the insured losses where operators have been involved, or because the operators don't really know what they're supposed to be doing, because they haven't had access to those operator manuals, they haven't had the formal structured training, they haven't had refresher training. But the other side of operators is that we see a lot of losses that happen because the operators don't practice the things that they're supposed to do in the emergency operating procedures. The picture of a turbine that I put up earlier, actually, it was the case that site had a training program in place. It was documented. They had a good management of change procedure in place. And in fact, there was an emergency operating procedure in the desk drawer of the operator on the night, which if he'd opened the drawer and read the procedure, would have stopped it from happening. But because they didn't practice how to deal with emergency events, they'd never practiced opening that drawer and going to the relevant page of the emergency procedure. So the whole operator training thing it's a bigger beast, just making sure they've got an operator manual. It's about reading it, understanding it, training it, practicing it, and making sure that there's a consistent response from the operators when things go wrong. And they do use the operator manuals, but they make a point of using them and recognizing when to use. So when a red light comes on, what do? Do they stick a piece of sticky tape over it because it comes on regularly? Do they take the bulb out because it's on very regularly? Or do they take the thing out the drawer, work out what they should be doing, and fix the problem properly? Hopefully that answers the question.
Thanks, Steve. Our next question is from Pavitra Bansal. Why does this approach not cover the whole asset life cycle, starting from design, construction, installation? And how does it capture computer-human interaction associated risks?
Sorry, you broke up a little bit. Could you read that one again, Simon?
So the first part of the question from Pavitra is, why does this approach not cover the whole asset life cycle, starting from design, construction and installation?
Well, it does. The aide-memoire app actually starts with the design considerations of the equipment. And that's the bit we never used to do before. We used to rock up on site, the client's got what they've got, how do you maintain it? And they would quite often bring out the OEM manual and it says you do this. But now we look at the system as a whole and we ask those questions. Is this machine designed to do this job? Because if the answer is no, then the whole of the rest of the system needs to recognise that. The maintenance, inspection, testing, every aspect of that asset integrity program for that asset needs to be reviewed because it's not being used for what it was designed for. It also looks at what was as part of the design, what safety devices, what mitigation has been put in place, what considerations have been made around where it's been fitted and what it's been fitted for. So that's the whole point of what we're doing. We are going right back to basics and considering everything from design right through to learning lessons when things go wrong to make sure that we make it more resilient going forward. We're looking at an entire system now rather than a please show me your records for the MDE on this bearing.
Sure. And the second, yeah, absolutely, thank you. And the second part is how does the approach capture the computer-human interaction associated risks? I think you touched on that earlier, but any comment that you wanted to add?
It's by focusing on a holistic system and asking the questions, what's your strategy? And then going on to say, and how do you deliver that strategy? It doesn't really matter how they deliver it, whether it's a computerized system or it's things that people are doing. We're less interested in how they're doing it and more interested in, is that an effective way of delivering that strategy? There are some sites I've been to where they've got the utmost in computerized systems for managing their maintenance and testing, and there are other sites I go to where they've got a tram ticket board on the wall. And both sites, they were top line actually. They've got different approaches, but the key thing is, was the strategy right for the equipment and systems that they've got to maintain resilience? So our approach, we've got an aide-memoire, and instead of just ticking boxes, we're going through the aide-memoire, investigating the strategy, investigating what's been put in place, and making sure that that matches the strategy that's suitable to maintain the asset.
Right, great, thank you. The next question is from Harry Moss, man after my own heart. Do FM Global offer an assessment service where recommendations are provided to assist the client improve asset operations and integrity or maintenance strategies towards best practice?
Well, in terms of our field engineering service,
yeah,
all our insured clients have access to our field engineers, and we will go along we'll apply this systems approach analysis to what they're doing and make recommendations if we think there's room for improvement. So yes.
Yeah, so absolutely. So if you're an FM Global client, this is a service that we offer to everybody. Next question is from Mike Burgess. Do you see a place for the use of statistical tools and models in establishing risk? And if so, which tools? And he's given some examples of regression, classification tree, neural network, or AI learning, perhaps. And if not yet used, do you anticipate using in the future?
Well, FM Global actually uses analytics a lot in working out how to improve not just our own business, but how we help our clients to improve their own businesses. And there's a really good blend to be made across practical experience and practically putting things in place and using analysis of loss history and failure methods, failure mode effect analysis. These are all tools really which support those practices. So yes, most definitely. The more information you can analyze effectively to work out potentially what could go wrong, the more chance you have of developing an asset integrity system which stops it from going wrong. So all of the, yes, if you can make them produce realistic information that becomes useful to us.
Cool.
One of the problems we do see though when we go and visit sites is they start collecting information because they can collect it, and they don't actually make good use of it. The knack is to collect information which you can transfer into good lessons to learn, and then transfer that through your management of change program into practical differences to the way you operate the plant to improve that resilience.
So being effective at using big data.
Yes.
Next question is from Jason Nico. How often or to what time period should maintenance strategy be reviewed along with operator competencies?
Operator competencies, it depends what the operators are doing, and it varies from site to site. It can vary from 6 monthly to 5 yearly. Depends on how what the likely skill fade is for the operators, and that has to be, there's a judgment call to be made on that. But the other side of it is what's the consequence of a failure because the operator does something wrong. That can also influence that periodicity. In terms of the asset integrity program, once it's established, there should be an ongoing review process. And again, it's down to a judgment call every year, every 2 years, some pieces of equipment every 5 years. There's no fixed time scale, but yes, all of these systems should be live. They should be subject to review, and because things change, materials change, products change, people change, and the review process is essential to make sure that the systems in place are still relevant, still functioning, and still delivering what they're designed to deliver. The unfortunate thing with a lot of the human element systems that are in place is that our clients buy a system or import a system, tick the box, I now have a system in place, and never change it. But in the course of 10 years, they might be producing something completely different with a different range of machines, and the system that they had in place is no longer relevant. We see that quite a lot. So yes, the system should be reviewed. Periodicity of that review depends on what's going on site. It's down to judgment, but yes, it should be reviewed.
Great, thanks, Steve. The next question is from Yu Hung Wong. I like the analogy that an operator is an organic safety operating device. How to benchmark the effectiveness of this organic safety device? Any suggestions?
The best way, in our experience, to make sure your organic safety device is functioning properly is to practice what they're supposed to do when things start to go wrong. So carry out drills on the emergency operating procedures. You don't actually have to shut the plant down, but yeah, have some sort of structured testing program in place, the same as you would with a trip on overspeed trip on a machine. You would want to know that it works. So periodically, during your maintenance period, perhaps you would go and test it and make sure that it operates properly. The operators sat in the control room. We should periodically get somebody to go in the control room and say, right, what are you going to do if this happens? Show me. Show me what to expect to see. Show me where the operating instructions are, the emergency procedures. Remove them from the desk. Show me the page. Tell me exactly what you would do, and practice it. Hopefully that makes sense.
Yeah, great. Thank you.
Don't ever call an operator an organic safety device.
Yeah, exactly.
You'll have to think of them that way, but don't call them that.
Well, maybe next question will be affected by whether you call them that or not. So we have a question from James Morrell that says, do clients still take operator recommendations personally or act defensively, even when explaining you are treating operators as a system?
In fact, I would say they view it more favourably. If you take an objective approach, you can always, the way you deliver these recommendations is really important. If we go to the client and say, actually, your operator as a system is rubbish, it's not working, that's not going to go down well.
Yeah.
But what we can generally go along and say is, actually, you do have an operator system in place, but there is room for improvement. By doing this, you can remove this risk. By doing this, you can remove this risk. What our clients really do appreciate is some sort of constructive feedback on how to improve the system, what areas to focus on, and then be able to relate that to what the consequences of failure are. So if you can make the case of this is the scenario if you don't do it, the potential scenario if you don't do it, and you can remove that scenario completely by doing this. So in answer to the initial part of the question, do the clients take it personally? No, they don't. They appreciate good, objective, positive feedback which can help them to get better. They don't always implement it, but if you deliver it in that way, it generally it's well accepted.
Excellent, good stuff. Next question is from Richard Asprey. What challenges did FM Global need to overcome to introduce these changes?
I think the biggest challenge was with our existing workforce. We've got a lot of engineers, a lot of experienced engineers, and part of the challenge was to convince our own engineering workforce that there was a better way to do things. And so the way we did that, as well as the changes to our own training organisation, we did a series of seminars at each of our offices around the world. And the approach we took was to actually use some examples to demonstrate that we could do better. And then on top of that, we've also made, I can't understate the importance of the new tools that we've introduced for our field engineers. They really are critical. It's all well and good asking people to do stuff, but if you don't give them the right tools to do the job, you're never going to get anywhere. So we very quickly had to develop a whole range of tools for our engineers to use. Things like teach them how to do an effective operator evaluation without offending anybody, but getting to the root cause of the problems with the system. The same with the asset integrity, moving away from tell me what maintenance you do and show me the measurements on the bearings on your flux capacitor turbine, to tell me about the strategy for making sure that what you're doing is the right thing to identify problems before they occur. So the things like the aide-memoire that I put in the slideshow actually is a back-to-basics tool for our engineers to take on site and say, tell me about the system as a whole. I don't particularly want to see the exact records for that bearing. I want to know why you're taking that reading of the bearing and what that reading is telling you. It goes back to an earlier question of a lot of our clients collect data and they've got no use for it at all. So the new systems approach and the tools and getting our engineers to think differently is about asking, why are you collecting this data and are you making good use of it? It's all about strategies.
Thank you. Next one's a very quick one that I can answer. So question from Will Wildsmith. Can I work for FM Global, please? Send me your CV and I'll have a look. Thank you for your question. Moving on. Next one from Temiato Borisard. How would you define the extent of changes that requires a management of change? And would you agree that this should extend to people as well?
Percentage of changes that require a management of change. Everything should be considered for management of change. And the key question is, could the consequence of this change extend anywhere outside of the immediate environment? Then the answer is yes, it needs to go through a management of change process. The process shouldn't, a lot of people view management of change as a big onerous process which involves lots and lots of people, and it shouldn't really be like that. It should be a logical, documented, step-through decision-making process which involves the right people for each change that needs to take place. And in terms of should it involve changes to manning and people, most definitely. One of the most common things I see in the world of rationalization and optimization of businesses is that businesses change their management structure. They change the number of operators. They put a new piece of equipment in which is semi-automated and they change what the operators are required to do. All of that go through the management of change process to make sure that if there's a requirement for changes to the training, it's implemented. If there's a change to the operating procedures, it's implemented. And everything that goes through that management of change procedure needs to be captured so that, and the system needs to be complete so that from the first idea, it goes all the way through and the questions arising from that management of change are included on the site action list and get completed, so that everything does make it through to the final documentation. So when the operator, in the middle of the night, when things go wrong, opens his drawer and opens the emergency operating procedure, the piece of equipment that was changed 3 months ago, the information on how to operate that in an emergency is in that documented procedure. So yes, what percentage goes through? In my experience, it varies massively, but I would say 60 to 70% of the changes that I see on site should go through a management of change procedure to some level. And the other thing is, don't forget, management of change covers everything from installing a new production line to fitting that jumper cable in the middle of the night even if it's just till the following morning. That is a management of change, and there needs to be something in place, even to deal with the short-term stuff, just to make sure it doesn't fall through the cracks and get forgotten. Hopefully that answers the question.
Absolutely. So we're almost approaching time, so I think a couple of extra questions just to squeeze in. So from Andrew Dugan, the systems approach as described is very similar to independent safety audits in the aviation world. Have you brought in any best practice from aviation, or thought of offering this service to aircraft operators?
We have had some input from a couple of engineers who come from the aviation world, and yeah, we took quite a few of their ideas on how they audit their own systems. And aviation isn't the only specialist area we took a lot of input from. The chemical industries have used something called process safety management for years and years. And there's a lot of the elements of process safety management, which are control and management systems, which now come through to form the backbone of the toolkit that we have created for our field engineers. In fact, we've created a whole new, in fact, it's not new, it's an updated data sheet for all of our clients to view, which is called process safety. And it includes all of those things like operator training, management of change, having strategies in place, asset integrity. That's all part of process safety. So do we offer it to other industries? No, we only provide a service to our insureds. And if they happen to make aircraft, that's fine.
Great, thank you. Just two more I think we can squeeze in. So from Clive Atten, are we sometimes guilty of information overload when attempting to deliver training to operators to a point where they become disinterested?
Absolutely. And that's one of the biggest challenges in making sure that operators are trained and competent. We can throw an operator manual the size of a telephone directory at an operator and say, there you go, that's it, read that, you're now qualified. That's not the case. What we need to make sure is the operators know what to do, when to do it, and it needs to be as simple as possible. Quite often I'll go to sites and they'll say, show me your emergency procedures, and they'll give me a ring binder which is full of pieces of A4 paper, and each piece of A4 paper has got maybe 20 or 30 paragraphs of instructions. The best sets of instructions for operators, the best way to train our operators is to say, when something goes wrong, you will recognize it by this happening. You must do these 6 things straight away, then go to the detail. So keeping things as simple as possible for operators is the key to success. Giving them more and more and more information actually increases the likelihood that they'll do the wrong thing when something happens. So yes, we are in danger of information overload. But that's part of the review we undertake now, is not to ask exactly what do you do to operators. We ask, what is your strategy for making sure that your operators do the right thing when something goes wrong in the middle of the night?
Great. Okay, so literally we have about 30 seconds for the last question from Vincent Murta. What range of reactions have you received from clients to your change to a strategic systems approach?
What range of reactions? I haven't seen a bad reaction to it. They appreciate a change of approach, and virtually every client I've spoken to has already recognised that the real risks they face aren't from the equipment. Our clients know their equipment. They know what's dodgy about a turbine or a compressor or whatever it is they've got. They're very well versed on the risks they face from that. What they're not so well versed on is the wider risks, the stuff that I talked about in the presentation. and in particular the human element systems. Everybody I've spoken to where we've made new recommendations, initially sometimes there's a lot more recommendations, but when they read the content of the recommendations, actually they're usually very well received. The clients acknowledge that, yeah, there is room for improvement, and they'll consider it to take it forwards.
Right, excellent. So look, we're at our allotted time. I'd first of all like to say thank you to Steve for being our presenter today. Thank you very much, Steve. I hope that all of you that have joined today have found this interesting and useful in whatever walks of life that you're working in. I'd like to say thank you for all of the questions. There are many other excellent questions I can see in the chat that I apologise we haven't had time to get to. I'll have a conversation with IMechE, and if we can get those downloaded and get answers to you, we will do our best to do that. So thank you for posing them anyway. These kind of events only work with the interaction of the audience, so thank you very much. The session has been recorded, as well as the presentation, which will be made available to you through the IMechE website. So thanks very much indeed. Stay safe, stay healthy, and look forward to seeing you at the next webinar. Thank you for your time.
Thank you all.
Thank you.